Welcome back. Second part of the Lunchbox plugin. This will be script number 42, and we'll try and get through the last 11 or 10 of these and highlight some plugins. Lunchbox is great at getting you thinking about machine learning. Download the examples from the creator at Proving Ground and get started. That's basically what I did. So I'm not taking credit for this. I just wanted to show that online these things exist. You can load them into your folder and take a look at what's happening. I'm going to put it on that we're only looking at what we're actually selecting, and this is where you want to go, the copyright as to what's happening. These files definitely you can pull from GitHub and use them. What do they actually end up doing? We're going to go in here and grab a top view and take a look at a point system of creating points. And they actually had a lot of data that they brought in that you can gumball and change whenever. And that's a list of points. And from that list of points of constructing it, they've deconstructed it so you can get the X, Y, Z attributes, and it's saying if the inputs were this X value and the output was this Y value, what would happen? There's just some nice color tools in here under the render to make it look a little more interesting. I believe the points would have a more interesting color function. I can take off my gumball, maybe get rid of that. But you can move these around and play with them. It's a linear regression node that gives you results and constructs a point from it. So basically, maybe it'd be best if I just left it and shaded. You can see from that original data right here that you're getting this point system that's a line, a polyline through it, and makes a prediction. And then you can customize the wavelengths and you can put it on to any visuals that you want. So rendered, you're ending up with that image. And I think I'd have to pull here. Why am I having trouble with the T's, the thickness? So I'm just thickening that, and I can thin that and play off of that. I have to wonder why my color's so ugly. Probably have to put on my render. There we go, to have a look at it. So it's a pretty simple system that's written. They'll walk you through a nice tutorial and you can understand linear regression. The next one they show an example of, once again copyrighted from the Proving Ground 2017, is you have a series of points. You're going to use an entwine from the Y and Z component. And the reason this being, you're going to be working in 3 dimensions. So you'll go to your visuals here and realize you have a cluster of points and you want to end up predicting the output of a series. If X was to come in, where would it end up landing on a 3-dimensional surface? And there it is. Exactly the same thing with a little bit of data set control, working through the tree nodes and what you actually have to end up using, and then you can pull that color through it as well. So I'm going to put it into rendered again, and you can see that predicted value. And maybe it's good to put everything on so you can see how that is driving that data. There's a few other things here that I should probably remove from the beginning stages, the basic setting. Let me take that to disable. So we're actually only looking at the lines that are being generated. And there you can see our original blue, and you can see our line from before. Proving Ground then continues. So that was a multivariate linear regression as opposed to the first one. And then they go through and they show another example of grabbing these points again. We're going to grab these by selecting what we're choosing. Another 3-point, actually it's a 2D perspective, so we can just go to the top view. And you're going to have a little bit of finesse from Sigma and from Complex to actually generate that line that flows through here. So that curve you can actually play a little bit and have a little bit of feedback onto what you want. So there's a little bit of human hand within this and human preference as to what's actually coming out. And they just have these constantly non-linear solvers. Everything's touched up in the Lunchbox. I won't spend too much time on it on these tutorials because I'd rather walk through them. And you can get through all the basic, 10 types of what machine learning is actually handle, and there's a nice render in the end. So if I put it back, you'll see all 3 of those already. The first linear, the 3-dimensional one, and then one that behaves more like a non-linear solver. Very nice. And then the last one they go into, the scripts there, and I've honestly just taken it off the GitHub and what's available to you. I encourage you all to do that. And from random nature of things, if we go in here and we actually produce a random and get a series of points that actually pop up. If I take a look at Z, we're actually dealing in an XYZ. You can bring up the count if you want. They've hard-coded things in using a little bit of entwining and changing matrix. You can get in and find the dot prediction of what's there, and they're using a non-linear regression to come up with this point system, which is right here. So it actually finds its own grid, constructs its own surface from points if you want to take that to surface from points or mesh from points, it makes a predictive model from the data you have as to what a surface would look like. Pretty fantastic. I know it's a quick overview. I'm not teaching it because it's not my content, but I want to give a quick reference for getting into Lunchbox and dealing on a more advanced level with the machine learning nodes. And you can go so far as to jump into the maths, and I do have a whole script series on GitHub that you can download the Rhino, GH-Python Rhino script. And maybe I'll just do a little plug for that. I'm not sure what I have here. If I go into GitHub, what I have on GitHub, if you go in and you take a look at Python one-liners and you go into the intermediate advanced, I've actually scripted all from the one-liner Python book, GH Python scripts that will help you out completely, moving through k-means clustering, basic statistics, random forest ensembles, and these are all one-liner scripts that run a very condensed user object node, and these are the user objects that you would want to bring into your components or user object file or special file for Grasshopper. And that's something I put out that's open source, and anybody can jump on there and grab that. So I'll move my head and you'll see it's just GitHub, Wickerson, one-liner Python user objects. There's also a whole bunch of other stuff that you might find interesting. And it's nice to see the following going up. That's a pretty fast tutorial of